Pedigree analysis is a tool used in genetics to study the inheritance pattern of a trait or disease within a family. It involves the construction of a diagram known as pedigree chart represented by standard symbols, which shows the relationship between family members and the presence or absence of a particular trait or disease. Pedigree analysis is an important tool in genetic counseling and can provide valuable information for families at risk of inherited diseases.
There are two main types of pedigree analysis. The first type is the sex-linked. Under sex-linked is X-linked dominant, X-linked recessive, and Y-linked recessive. And the second type is the autosomal. Autosomal means the gene is located on any chromosome, the X or Y chromosomes, which are the sex chromosomes.
But we'll focus on the autosomal. An autosomal dominant disorder requires only a single copy of the mutated gene from one parent to cause the disorder. A recessive means that two copies of the mutated gene, one from each parent, are required to cause the disorder. An example of autosomal disorder is dwarfism. Dwarfism is short stature, generally defined as an adult height of 4 feet 10 inches or less. Now let's talk about the pedigree analysis of a specific type of dwarfism, achondroplasia. Achondroplasia is a disorder of bone growth that prevents the changing of cartilage to bone. It is an autosomal dominant genetic condition, which means that this condition often doesn't skip a generation of families.
We have 3 generations of affected families of this condition. As you can see, there are affected individuals from the grandparents to parents and to children. For us to further understand, we will represent the condition with the letter A. Homozygous dominant is a double big letter A, and heterozygous is only have one big letter A and one small letter A. Homozygous recessive is only have 2 small letter A. Among these genotypes, individuals with a homozygous dominant and heterozygous alleles will inherit the condition, since achondroplasia is a dominant inheritance.
For the first generation, we have here the grandfather and grandmother of both families. Both grandfathers had been affected by achondroplasia. To determine its genotype, we are going to look at the second generation. Here on the left side, both the sons have been affected. Therefore, the grandfather has a homozygous dominant allele. On the right side, both the daughters have been affected except the son. If he has the homozygous dominant allele, then we would expect all of his children to be affected. But the fact that the son is unaffected, that means he didn't get the dominant allele. With this, we can conclude that the grandfather has a heterozygous allele. These will then be the genotypes of all individuals of the 3 generations, having 4 males and 4 females affected by achondroplasia. The example pedigree chart of achondroplasia then contains the features needed for an autosomal dominant pedigree chart as stated below.